Hi everybody. I thought it would be easier if I did the ears PowerPoint in a couple of screencasts for you so you can view those outside of class on your own time. Because we have the exam on Monday, we won't have a lot of time to go through both of the PowerPoints. So this one's on chapter 15 and the ears. A lot of it is very self-explanatory and you can read the explanations in the book. So I won't go into a whole lot of detail, but hopefully it'll hit some of the highlights for you. All right, structure and function of the external ear. Remember, the outer ear is called the auricle or the pinna. The auricle or the pinna. And remember when we took a temperature in the ear in class, I said that it would be labeled AU, and that's because of the auricle. There's the auditory canal that leads down to the eardrum, also known as the tympanic membrane. Remember that the outer third of the canal is cartilage, as is the pinna. The outside of your ear is cartilage as well. The tympanic membrane, of course, is the eardrum. It separates that external and middle ear. When you describe it, when you look at it, when you get to see it in class, you're going to see that it's kind of a pearly gray color. So think about the color of a pearl, but add a little gray into it. It's oval, it's slightly concave, so it pulls in, and it's pulled in by the little bone in there, the malleus. Remember, there's 3 bones in the middle ear, the malleus, the incus, and the stapes. Hammer, anvil, and stirrup, also known by those. Sometimes things that you can see on the eardrum are the umbo, the manubrium, and the short process. And those pictures are in your book, and we will also talk about those more in lab as well. So make sure you look at those pictures. The umbo is kind of, if you look at the eardrum, it's right in the center of the eardrum. It almost looks like a circular little disc. The manubrium is the handle that kind of comes off of it. And then there is the little tiny short, I guess they call it a short process, but it's just a short little piece as well. All right, so here's a good picture that is of the ear, and you will see the external ear here, the pinna, the auricle or the pinna, the eardrum. Here's the tympanic membrane. The malleus or the hammer is here. Here is the incus, and then here is the stapes. And then it goes into the inner ear, and that's where a lot of your sense of equilibrium comes into play. All right, in the middle ear we have the tiny air-filled cavity that's inside the temporal bone. If you hear jingling, I'm sorry, that's my little dog. Well, he's my big dog, Chip, so hopefully I won't have to yell at him. So inside this cavity are those tiny ear bones again, those ossicles. That's another word for the bones inside the ear. The malleus, the incus, the stapes. The eustachian tube goes through there as well, and it connects the middle ear with the nasopharynx and allows the passage of the air. So remember, pharynx is throat and naso is nose. So in the back of your throat where the nasal opening and the throat meet is the nasopharynx. So the eustachian tube connects the middle ear and runs down into that area. It's usually closed, but it opens up when we swallow or yawn, and that's quite often why we feel the popping of our ears with that. The middle ear has 3 functions. It conducts those sound vibrations from the outer ear to the central hearing apparatus in the inner ear. It also protects the inner ear by not allowing the amplitude of loud sounds to prevent damage. So it kind of stifles that noise a little bit. It kind of absorbs some of that noise so that those loud sounds aren't quite as loud. The eustachian tube also allows equalization of air pressure so that the eardrum doesn't rupture. When there gets to be too much pressure, it is possible for the tympanic membrane to rupture. And I'm sure all of you have heard of someone having a ruptured eardrum. Excuse me, ruptured eardrum can be very, very painful. The inner ear contains the bony labyrinth, and this holds the sensory organs. And again, as I said, it's for equilibrium, so it's for balance, and it also is hearing. So the inner ear, the two functions of the inner ear are equilibrium and hearing. The vestibule and the semicircular canals, they are in that bony labyrinth, and they compose the vestibular apparatus, and that is the one that is specifically, the function is for equilibrium or balance. So if that gets off, or if you have damage to that, you'll see people who are kind of off balance and unable to stay upright. When we get up too quickly, you've maybe gotten dizzy before when you've gotten up too quickly, and that's the area that is affected with that. The cochlea is the central hearing of your ear. So that is the main hearing apparatus. So the inner ear itself is not accessible to direct examination. We can't look at it, but we still can assess the function. So while we can't directly look at the inner ear, we can assess how well they hear, how well they're balanced, and you'll see how we do that in lab this week, where you may have the person stand there and with their eyes closed and make sure that they're not kind of wobbling back and forth. And then, of course, we're going to check hearing as well. So hearing as one of the functions, the auditory system can be divided into those three levels. We have the peripheral level, the brainstem, and then the cerebral cortex. At each level, different things happen. At the peripheral level, the ear transmits the sound and converts its vibrations into electrical impulses, which then are analyzed by the brain. So peripherally, the ear picks up those sounds, transmits it through to the brainstem carries it to the cerebral cortex analyzes it. Also, with that is the process of defining that amplitude or the loudness of the sound that you're hearing. And then we also can hear the frequency, so the pitch of the sound. So not only how loud it is, but is it a high pitch sound or is it a low pitch sound? And one of the tests that you're going to be doing this week is where you'll wear the headphones and you'll test each other's hearing by listening for the different frequencies and the different sounds, and we'll vary the pitches and the loudness as well. Okay, sound waves are produce different types of vibrations on your tympanic membranes, and that's the tympanic membrane, and that's how sound is created. These vibrations are carried by those bones in the middle ear to the oval window. And if you have your book available, you might want to turn to that picture again and just kind of look at these structures. Then the sound goes through the cochlea and it goes against what's known as the round window, where it's kind of dissipated. So if you think of something dissipating, it just kind of disappears. When there's the basilar membrane, and it vibrates according to the frequency of the sound. So again, that high pitch or that low pitch will determine how that basilar membrane works. And then this goes along until it hits that organ of Corti. And the organ of Corti, this is the sensory organ of hearing. Really important for you to know that. Organ of Corti is the sensory organ of hearing. So the hair cells on the organ of Corti bend and kind of send those vibrations, turn those vibrations into electric impulses, and then again travel through cranial nerve 8 to that brainstem, where then they go up to the cerebral cortex and are processed by your brain. Normal pathway of hearing is air conduction. It is the most efficient. So that would be where if you just kind of move your fingers on the outside of your ear, the the air conduction is what you're hearing. The sounds are going through the air. Versus if you use a tuning fork, which you will be practicing with in lab today, you can cause vibrations on that tuning fork. And if you hold it on the top of your head or hold it on the mastoid bone, which is behind the ear, you'll be able to hear those vibrations as well. And that's known as bone conduction. So this picture comes from your book as well. And if you tapped that tuning fork, you would have the vibrations, and if you just hold it outside of the auricle or the pinna, you would be able to hear those vibrations, but the sounds are being conducted through the air. Versus if you come up here and look, you'll see that we're touching the bone, so we're touching that handle, which is right here of the tuning fork. We'll touch that right up against the bone. Quite often they'll do it on the top of the head so that they can tell if you can hear the vibrations on both ears equally, if the sounds are transmitted through the bone to both sides of the ear. And then we can do specifically on one side. Again, we're going to touch that mastoid bone behind each ear. All right, this is a video that you can watch on your own. Just kind of talks about that hearing mechanism. I won't take the time to watch it, but please go outside of class and watch it on your own. All right, hearing loss. You will be dealing with a lot of people who have various forms of hearing loss. As we get older, we start to lose some of our hearing, and that's kind of one of those normal physiological changes of aging. We've heard many times that some things shouldn't be associated with aging. Unfortunately, hearing loss is one that is. So a hearing loss, anything that obstructs the transmission of sound impairs hearing. Now, this can be caused from something physiological, with like the person getting older or some kind of damage to the system, but it also can just be caused by something as simple as something plugging the ear canals, like wax, or maybe some type of an object. Unfortunately, we have kids that stick things in their ears. I've also known of people who've had moths or bugs crawl into their ears, and that can cause that problem as well. So a conductive hearing loss involves a mechanical dysfunction of the external or the middle ear. So a mechanical dysfunction. So something is physically injuring or impairing that external or middle ear. It's a partial loss hearing because the person can still hear if the sound amplitude is increased enough. But this is the one that I'm talking about, could be caused by impacted cerumen, which is earwax blocking the ear canal. Foreign bodies, as we talked about. It also can be caused by that ruptured tympanic membrane or perforated tympanic membrane. Sometimes there's pus or there's serous fluid that's trapped in that middle ear and it's unable to drain out. Otosclerosis is where we actually have stones. So you've all heard about kidney stones. You can get stones in your ear as well. And those are called otoliths, O-T-O-L-I-T-H. And otolith is a stone found within the ear, and that can cause problems as well. And otosclerosis also could be caused by just those bones not being able to move appropriately. I'd like to back that up just a second. Otoliths and otosclerosis are different things. So go back and change that. An otolith is a stone, and that would be a mechanical, a foreign body. Otosclerosis is hardening of those ossicles so they don't move as well as they should. I'm sorry, I got ahead of myself when I saw the word otosclerosis. So otolith is a stone that you see in the ear, and it can cause hearing loss. Otosclerosis is where we have hardening of those ossicles. Think of arterial sclerosis with hardening of the arteries. Okay, I'll be back.